So what we have here, let's go to the next one. So the outline of this presentation is as follows. First, I'm going to introduce you to gears and some terminology that we use when we study and design gears. Second, I'm going to talk about the classification of gears. So because we have several types of gears, we have spare gears, we have helical gears, we have bevel gears, we have worm and worm wheel, and so on. So we are going to go through these as well. The profile of the tooth of the gear is called involute. So we are going to talk about involumetry, why we use involute teeth profile. There is a strong reason of using that. So you should understand what is involute curve and why we should use it for gear teeth. Okay, we're going to talk about gear theory as well. We're going to talk about some kinematics of gear and gear design in the end. Okay, so this is the outline of today's class. I'm going to share this presentation with you at some point. So when you come to this screen, for example, if you click this link, it will take you to a YouTube video. I'm just recommending that you please watch these videos. They are quite nice. They will give you some more information about gears. You will see several links like these. So please try to watch them when you see them on the slides. Okay. I found this nice GIF picture on Wikipedia. And actually it shows you here this small red gear and this big blue gear. Normally in the terminology of gears, they call the small gear pinion, and then they call the large gear, they call it wheel. So we have pinion, the small one, we have wheel, the large one. Sometimes they call the large one gear as well. So pinion is the small one, and the big one has two names. Either it is gear or it is wheel, okay? So what you see here is that you see two gears. They are meshed together. They are used to transmit rotational motion. So if, for example, here you have the center point of the first pinion gear, and here you have the center point of the wheel, right? Then you consider that you have a shaft here. If you have a shaft here and you have another shaft here, and then you want to transform or transmit the rotational motion from shaft number 1 to shaft number 2. So one way of doing that is to use gears. So gears are used to transmit power, transmit rotational motion between two shafts. These two shafts could be parallel shafts, could be perpendicular shafts, they could be skewed shafts. We'll see how we can deal with each and every configuration of these, okay? So second, note that the smaller gear, which is, I said this guy's, the name of this guy is pinion, and the name of this one is wheel, okay? So the smaller one here rotates faster compared to the other one. So what we do here, if this is the input and this is the output, so we are just reducing the speed now, right? Because this one, the pinion, rotates faster compared to the wheel. So we are just reducing the speed, okay? So the larger gear here rotates less quickly. So the torque on this gear or on this shaft is higher compared to the torque on this one. So the whole idea here is that, imagine guys, on the pinion shaft, there is an electric motor. So the electric motor here produces a specific amount of power. And if we want to transform this power from the pinion gear or from the electric motor shaft to a gear pump, for example, or a fan, okay? So you want the gear pump here, if the gear pump is connected to the wheel shaft. So we have here electric motor, and then connected to this shaft, you have gear pump. Right. I said if we have here, let me bring my pen. Right. So if we have here electric motor, it rotates at specific speed. Okay. Normally it is fast. Okay. And then on this shaft, you have a gear pump or a pump, just simply a pump. Okay. And then what we need here, we need the speed to be small, but we need the torque to be high in here in this case. Here, normally the electric motor produces high speed, high omega, but the torque is normally small, okay? So using this gear set that you see, we can do this. We can convert the motion so that in converting this motion, we can reduce the speed and at the same time we can increase the torque. Why? Because the power that is transmitted from here to here is constant. So, and the power is equal to the torque times omega, right? So if the power is constant, when you reduce the speed, you can increase the torque and vice versa. Good. So in this case, the larger gear here or the wheel rotates less quickly, but the torque here is greater. Okay. So the linear speed at the pitch diameter. So there are lots of just definitions that you will see for gears. One of them is called the pitch diameter. So the pitch diameter is an imaginary circle which is here. It's intermediate between the top and the bottom of this wheel. So if there is a pitch diameter for this wheel and a pitch diameter for the pinion here, these two pitch diameters at this point here, where the two pitch diameters touch each other, so the distance between the center point of this pinion till here is the radius of this pitch diameter for the pinion. And the distance between the center point of the wheel to here to the pitch circle of the wheel is the radius of the pitch circle for the wheel. At this point, at this pitch point here, the linear velocity of both the pinion and the wheel is the same, similar. Okay. So what you see here on the screen is a machine. It's very complicated. You see lots of gears and the motion is transformed from one shaft to another shaft to another shaft. Sometimes the gears are used to only transform the same amount of rotational motion. So there is no increase or decrease. For example, if I assume that these two gears, this gear and this gear, they have the same diameter, so their speed or their rotational speed is going to be the same. So here we are maintaining the speed. But if you look at this gear and look at this gear, so there is a difference in the pitch diameter between them. So here we are just increasing the speed of this shaft. Okay. So the toothed gears, they are used to transmit motion and power between rotating shafts, as you've seen on the previous slide and as you see on this slide, with a specified velocity ratio. So the velocity ratio here, if the pinion rotates with a specific rotational speed and the gear rotates with another rotational speed, the ratio between the speed of, or the rotational speed of the pinion and the rotational speed of the gear, it is called the velocity ratio. And this velocity ratio is quite important. We'll talk more about this in the slides to come. There are other ways also of doing this, of transforming or transmitting motion and power between shafts, okay? One way of doing this is using pulleys. So you have two pulleys and then you have a belt between them. So you can transform the power and the motion using pulleys, a set of pulleys and belts. You can use chains. It's similar to if you have a bike. So there is a sprocket at the front, there is another sprocket at the back, and there is a chain that is connecting them. This set, like the sprockets and the chain, this is one way of transforming motion and transforming power between the driving just the pedals and the rear wheel. Okay, so friction discs, this is just if you have two discs or you have two cylinders, they are touching each other, they are tangent to each other. So due to friction, so they can rotate each other, they can transform the motion and the torque between two shafts. So this is the first friction disc, for example, the second friction disc, if they are like this. So the friction here, so the center point, and then when this rotates in this direction, so this will rotate in this direction, and you can, the motion and the power can be transformed between them. Okay, each and every one of these methods, they have their own advantages and disadvantages, of course. Okay, but the good thing about the gears is that they provide positive drive without slip. So slipping can happen in here, for example, and especially here. But for gears, they provide positive drive without slip. There is no slip between the teeth when they rotate or they just drive each other. So gears obviously are capable of transforming very high levels of torque, okay? And they can be found in every machine around us, okay? Including, for example, cash machines. When you go and get some money, so you hear this voice of something that is rotating inside. There are lots of gears that working behind the scenes to bring you the money that you want. For example, the cash machine, it has around 50 gears. So automobiles, when you drive on the road, so the engine of the car, it works with it produces useful torque and useful power within a specific range of speeds. But the requirements of the road, sometimes we need to drive slowly, sometimes we need to drive fast, and so on. So between the engine, if this is the engine of the car, so this is the engine, and here is the differential at the back, and you have the axle for the rear wheels, and we have here like the driving shaft. There is here a gearbox. Okay, so this gearbox here is used to transform the energy, transform the motion, and provide us with different kind of torques, different levels of speeds to the axles at the back here. Okay, so if the engine works within specific range of speed, so using the gearbox, we can shift the gears so that we can either drive the wheels at the back here slowly or fast. Okay, so this is another way of using or another application where gears are used. So use gears for increasing torque, so you can increase the torque between the engine and the drive of wheels. This is what I was talking about. Also, we can use it for windscreen wipers, these wipers that you use during winter, and also when you wind down or up your window, the glass window. Okay. The power stations and ships, for example, they have huge gearboxes and they are quite expensive. They can cost almost 1 million pounds, British pounds, for example. What are the functions of gears? Okay, so as I said earlier, the good thing about gears is that they provide a positive displacement coupling. There is no slip here between the teeth of the gear. So they provide positive displacement coupling between shafts. And of course, this means that the power loss is very small. The efficiency is very high because if there is slip, so it means that there is friction, there is power loss, and the efficiency goes down. So we can use gears either to reduce the speed and the torque, to increase the speed or the torque, or to maintain the speed and the torque. So it is the power is equal to torque times omega. So it depends on what you need to do with your gears. You can maintain the speed between two shafts. You can increase or decrease the speed. You can increase or decrease the torque. Okay. It can also use to change direction. Remember, if you have the pinion and then you have the gear, okay, then if the pinion, for example, rotates in the clockwise direction, so the gear is going to rotate in the counterclockwise direction. Okay, so you can hear direction, you can change the direction of rotation. If you wanted these two gears to rotate in the same direction, so either you use what's called internal gears, or you can use an idler gear between them. So if you use another intermediate gear in the middle here, so eventually you will have 1, 2, 3, for example. So eventually these two will rotate in the same direction. So what you see here is an example of a good design, a very good design of a gear. So it is the main propulsion gear of the transatlantic linear Queen Mary. This is a very huge shape. Then they have opened the gearbox after 11 years. And then this is what you can see. They haven't found any wear or tear or any damage to the gears because they are properly designed, they are properly maintained. So what we want from gears, actually, so we want from gears to provide efficiency, which is there. Gears can provide 95 to 96% efficiency, for example. The pore loss is very, very small. They are reliable. So something, example like this, after 11 years, there was no sign of wear or damage. So they work for a long time without damage or breakage. We need accuracy, and you see, because they provide positive displacement coupling, so they are quite accurate in transforming motion and power. Smooth transmission of power and motion, and low noise as well. If they are well maintained, if they are lubricated and so on, so the noise level is quite small. The message here is that they provide positive drive without slip. Okay, so losses are quite small. So the figure below here shows you how industry uses mechanical drive components, right? So, and you see here, if the share of the gear drives is very huge, actually. It's almost 50%. So almost 50% of the drives that are used in industry are gear drives. So there are other options or other applications like chain drives, couplings, belt drives, adjustable speed drives, clutches and brakes, indexing and positioning devices, etc. But the good thing is that here gears, they have the 50% share. So they are commonly employed in mechanical transmissions. Why? Obviously, first of all, they are versatile, so you can transform motion between two parallel shafts, two perpendicular shafts, between two skewed shafts, and etc. You can play with the speed ratio, with the torque ratio, and all these things. They are compact, so you can transform high level of power, or you can have a high ratio of speed, rotational speed, within a compact space or a small space. Their efficiency is quite high compared to other drives, as you have seen, because the losses are quite small. Unlike most belts and chains, we have two types of gears. One is called bevel gear. You will see in a minute the picture for this one, worm and worm wheel. So these two types of gears, they can change even the plane of rotation. So you have two perpendicular planes of rotation, and then you want to transform the energy and the motion between them, so you can use the bevel gear and the worm and worm wheel to transmit the power and rotation. I'm going to show you some pictures for this, and it will be more obvious. Okay. So gears actually provide power transmission over a wide range of speeds. So you still can, by changing the diameter of gears, you still can have a wide range of speeds and speed ratios. The only drawback of gears that they can be used only for short center distances. So because if the center distance are very large, it means that the gears are going to be very large as well. And then they will be very heavy, they will cost more, etc. So we need to think about other drive options in this case, okay? So some terminology here. Don't be scared when you see this picture, because eventually it's like 4 circles each, and then they are the same. So if you look at the top part here, it's called the pinion. Sometimes they call the pinion driver as well, because it drives the motion. It's the input of the motion. And the bottom one here is the gear. It's the driven. So in this case, because the pinion is smaller and the gear is larger, or the wheel is larger, so we are reducing the speed. We are reducing the speed. The pinion here rotates more and the gear rotates less, but also the torque on the gear is higher, okay? So if you look at the representation of the gear here, you will find that there are some names that you are going to learn as we go, okay? So if this is the tooth, for example, of one tooth of the gear, so you will find that you have the one circle at the top and one circle at the bottom of this tooth, okay? The circle at the top, it's called addendum circle, addendum circle. And the circle at the bottom is called dedendum circle, dedendum circle. We have one circle in the middle, okay? And this is like imaginary circle, okay? It is called pitch circle, pitch circle, okay? And we have one more important circle here, which is the solid line, this one, it's called base circle. You're going to learn more about the base circle in the next few slides. And then if you look at the top, you have again, the same 4 circles, okay? Same 4 circles. This point here, point B, when the pitch circle of the gear and the pitch circle of the pinion, they meet at this point, they are tangent at this point, it's called the pitch point, okay? We're going to learn more about the angle of approach, angle of recess, and pressure line in the next few slides. But just to keep it simple, you have the first shaft, the center point of the first shaft is here, and the center point of the second shaft is here. And you can represent the wheel, the pinion, and the gear by 4 circles each, okay? So we'll talk about this more. It is all based on this equation. The power is equal to the torque times omega. As I said, if the power the power that is going to be transmitted between the pinion and the gear is constant, so it means that torque times omega for the pinion is equal to, if this is constant, so torque times omega for the pinion is equal to torque times omega for the gear, right? So if you reduce the speed of the pinion, then in this case, the torque for the wheel is going to increase, okay? So you can just see that because the pinion rotates more, then the gear rotates less, and also we can play with the torque as well, okay? So the good news is that we have only 2 key theories, Pythagoras theorem, and also the trigonometry equations or relations. So not a lot of math behind these.